Hi and Assalamualaikum. I am Khazizul Helmi from Group 14. In this video, we will be presenting our Mechatronics project entitled Automatic Rain Sensitive Windshield Wiper. Before we start the presentation, let me introduce first the team member of Group 14. We are made up of 5 team members. Firstly, Muhammad Syauqellah bin Razali. Then we have Muhammad Aiman bin Khairul Azam, Ahmad Khairul Irfan bin Khalid, Muhammad Harith bin Side, and me, Khazizul Helmi bin Burhan. First and foremost, let's start with our project background. As we all know, windshield wipers are one of the most important safety systems available in our car. It was designed to keep our windshield clear from uh, debris, dirt, water droplets, or rain, so that we have clear visibility on the road. So windshield wipers typically consist of metal arms and a rubber blade that is mounted on the windshield. The arm will move the blade back and forth across the windshield to clear away the debris and water droplets. Depending on the amount of the rain, the speed can be adjusted. So in this project, we are innovating the windshield wipers by using sensor to detect raindrops on the windshield, and it will automatically adjust the wiper speed and also the frequency. This automatic rain sensitive windshield wiper system then will help the driver to focus ahead on their driving, while the system will take care of the windshield wiping. Therefore, it can improve the driving safety in rainy weather condition. Moving on to the problem statement for this project, as we may know, traditional windshield wiper are manually operated, where we can change its speed or frequency at the back of our steering. This method requires drivers' constant attention to adjust them. This then will distract the driver's attention away from the road, which is very dangerous, which then can lead to the increase in the risk of accidents. A statistic by WHO or World Health Organization, it mentioned that more than 2 million people die in accidents each year during rainy season. These numbers are very concerning, so the driver nowadays really need to aware on the safety of their car, especially in wet condition road. To address the issue just now, we had come up with two main objectives for this project. Firstly, to develop a reliable and responsive automatic rain-sensitive windshield wiper system. So the system will significantly improve the driving safety, making it easier and more comfortable to drive in rainy weather conditions. So next is our objective is to design a user-friendly intelligent wiper control system for optimal performance. We will implement the use of rain sensor and Arduino in this project, which we think will be giving an impact to the performance or efficiency of the windshield wiper system of a vehicle.
We will be discussing the literature review. Firstly, let's talk about the working principle of the project. The rain sensor is a key component of the system that detects precipitation on the windshield. When the sensor detects rain, it will send signal to the microcontroller, which then processes the data and sends a command to the servo motor. The servo motor then adjusts the speed of the windshield wiper based on the intensity of the rain. This process ensures the wiper operates at optimal speed for better visibility for the driver. Next, moving on to the Arduino. Arduino is a microcontroller platform that provides a flexible and customizable solution for controlling the windshield wiper system. It, it processes the data from the rain sensor and sends the command to the servo motor, ensuring that the wiper speed is adjusted accurately. The Arduino can program the wiper to be adjusted their speed based on the speed of the vehicle. Next, let's talk about rain sensor. Rain sensor is a vital component uh, to detect the presence of precipitation on the windshield. It uses a sensing element to detect raindrops. Then, when it's detected, the sensor sends a signal to the microcontroller, which processes the data and sends a command to the servo motor. Finally, the servo motor is used as a control of the movement of the wiper to ensure they operate at optimal speed for the current weather condition. They provide a precise and reliable solution for adjusting the wiper speed to ensure the better visibility and safety for the driver.
So moving on to the methodology section. So this is the project flowchart. This project aims to develop an automatic control system for the wiper, where the driver won't have to turn on the switch manually. A control system had been developed which contains rain sensor, servo motor, and Arduino microcontroller. So in this flowchart, sensors are used as the decision variable for the program. When rain sensors sense the water, the voltage will change. And when water intensity increases, the motor speed needs to be increased also. So when voltage increases, the motor speed automatically increases by sensing the water immersion level. So the LED becomes on when the sensors work perfectly. The physical decomposition of this project will be consisting of 4 subsystems, which are the sensor, the motor and actuator, the wiper blade, and also the wiper arm. So this would be the morphology chart for this project. So basically the function of every subsystem can be explained by the sensor system. It works by detecting the rain on the windscreen and sending a signal to the control module informing LEDs of its presence and intensity. The motor and actuator are used for physically moving the wiper across the windscreen. The wiper blade is in contact with the windscreen and removes the water and debris, and wiper arm is used to secure and stabilize the connection between the wiper motor and also the wiper blade. And each of these subsystems was given 3 choices to be opted into the design. For the sensor system, the choices would be the rain sensor, the optical sensor, and the infrared sensor. As for the motor and actuator, the choices would be the DC motor, the stepper motor, and also the servo motor. As for the wiper blade, this would be the material for the wiper blade, which consists of the rubber, natural rubber, and also the silicon rubber. And lastly, for the wiper arm, and lastly for the wiper arm material, which is the steel, plastic, and aluminum. So in choosing the best option to be used for the subsystem, an objective tree had been made. So every subsystem is just based on 4 criteria, which are related to its function. So all 4 subsystems was given an equal weightage, which is 0.25, as they share same importance in ensuring the success of the project. So the criteria for sensor are accuracy and response time with 0.3 weightage. So a high accuracy sensor with quick response time is important to make sure that the driver is safe while operating the wiper.
So this is the weighted decision matrix, the tool used to determine the material or the component used in each subsystem. So we have 4 subsystems in the automatic wiper system. So the first subsystem is the sensor system. The criterion for the sensor system is the accuracy, response time, durability, and cost. So the decision matrix, from the decision matrix, we give score to the components that we're going to choose. For this example, as a sensor is the rain sensor, optical sensor, and infrared sensor. So from the table, you can see that the rain sensor have the highest score, is 0.775 among the others. So it is the best sensor system we are going to use. Then we're going to take a look at the motor and actuator system, where the criterion is the accuracy, durability, efficiency, and cost. From this motor and actuator, we have 3 decisions. That is the DC motor, servo motor, and the stepper motor. And from these 3, the servo motor has the highest weight compared to the other motor. So it is the best choice that the servo motor is used. Similarly, in choosing the wiper blade, we have natural rubber, and silicon rubber. So the criterion for the wiper blade is the durability, performance, compatibility, and cost. And from the table, from the decision matrix table, you can see that the silicon rubber has the highest weightage, is 0.95 compared to the other wiper blade. Hence, we choose silicon rubber as the wiper blade system. Then for the wiper arm, we have the decision among steel, plastic, and aluminum, and the criterion is the compatibility, performance, noise, and cost. From the table, decision matrix table, we can see that the plastic wiper arm has the highest weightage, that is 0.875. Hence, from the weighted decision matrix, we can conclude that from all the 4 subsystems, we're using the rain sensor for the sensor system, the servo motor for the motor and actuator system, the silicon rubber for the wiper blade material, and also plastic for the wiper arm material.
Okay, so now moving on to the result and discussion part. So the first one is on the circuit diagram. From the circuit diagram, you can see how we're able to orchestrate the 5 components in order to satisfy the objective of our project. So from the table, the first component is the Arduino Uno R3, which acts as the microcontroller. The 2 slide switch, which is to switch off and switch on the ignition or wiper. The third one is the rain sensor, represented by the potentiometer, which is to detect the rain. The fourth one is the DC motor, which acts as the wiper motor to rotate the wiper. And the last one is the oscilloscope to show the frequency of rotation of the wiper. So in the project, we're able to accommodate one sensor, which is the potentiometer, which acts as the rain sensor, and one actuator, which is the DC motor for the motor wiper. Okay, so next over here, we can see the simulation of our project. The above one is the simulation of when the rain is not detected, and the below one is when the rain is detected. Okay, so let's see the first simulation. So when the rain is not detected, the DC motor or the wiper motor does not activate. Okay, so however, when the rain is detected, both the ignition and wiper switch is activated. The 2 wiper motors start to activate. And when the speed of rain is increasing, as simulated by increasing the potentiometer, the speed of wiper motor also increase. So now come the last part of the result and discussion, which is on the further improvement and recommendation. So the first one is to optimize the pulse width modulated signal, PWM signal. This can be achieved by using the PID controller, where the duty cycle could be adjusted continuously based on the potentiometer value, resulting in smoother and more efficient motor control. The second one is to use the external hardware such as relays or transistors to switch the motor on and off, hence reducing the load on microcontroller and provide reliable motor control. And the last one is to add the display to show the current potentiometer value and wiper motor speed to ease the process of current settings, and we can adjust if needed.
So in conclusion, the automatic rain sensitive windshield wiper is an innovative solution for adjusting the speed of windshield wiper based on changing weather condition. The project used rain sensor to detect the precipitation on the windshield, and the Arduino as a microcontroller to process the data, and servo motor to control the movement of the wiper. The project provides enhanced safety and comfort for the driver by eliminate the need for the manual adjustment of the wiper. Overall, the automatic rain-sensitive windshield wiper provides more reliable and efficient solution for adjusting the speed of windshield wiper, ensuring better visibility for the driver.